Hey Martin.
Hey Sal, welcome to Pub Math. I've got something interesting for you today. I'm going to show you Euler's identity, and then I'm going to show you how to derive Euler's identity. Euler's identity is named for Leonhard Euler, who was a Swiss mathematician, and his identity is perhaps one of the most elegant and wonderful things in the whole of mathematics. So without further ado, here's his identity. E to the I pi equals -1. We've combined e, which is the basis of natural logarithms, with I, which is the square root of -1, an imaginary number, and pi, the ratio between the circumference and the diameter of a circle. And we've even got -1, which is an unusual number. If you think of numbers as tools for counting goats, here's one goat, over there are 3 goats, this field has 17 goats. What on earth does -1 goat mean? How can you put -1 goat in a field? So we've put these 4 different numbers together in such a simple way, and let's see how this is derived. Now, to derive this, we're going to need what's called Euler's formula, which I'll write here. E to the I theta equals cos theta plus I sine theta. That's a complex number, cos theta plus I sine theta. Now, to derive this formula, we're going to erase the e to the I theta on the left. You see it's fading away, and we're going to replace it with f theta. So I'm defining a brand new function called f theta, which happens to be cos theta plus I sine theta. Now, next step, I'm going to take the derivative of both sides. The derivative of f theta is written as f prime theta. That simply means the derivative of f theta. And on the right, we get minus sine theta plus I cos theta. That's because the derivative of cos is minus sine, and the derivative of sine is cos. Okay, now I'm going to do something a little unusual. I'm going to write a fraction on the left where the numerator is f prime theta, and the denominator is f theta. There we are, there's the fraction. And then on the other side, I'm going to write it out as the 2 formulas. So we have minus sine theta plus I cos theta, and underneath we have cos theta plus I sine theta. Now, what we've got on the right is a mess. It's one complex number divided by another complex number, and we don't like that. So we need to do what's called rationalization. We're going to rationalize it, which we do by multiplying top and bottom by the complex conjugate of the denominator. So that happens to be cos theta minus I sine theta, and you'll see why this works in just a minute. So let's multiply top and bottom by cos theta minus I sine theta. Okay, let's multiply out the top. So we have f prime theta over f theta equals, multiplying out the top, we get minus cos theta sine theta plus I cos squared theta plus I sine squared theta plus sine theta cos theta. Now that fourth term is plus because it contains 2 i's multiplied together, which gives -1. Underneath we have cos squared theta plus sine squared theta. That's because we've got I sine theta times I sine theta, which is negative, so we get 2 negatives, gives us a positive. Now, look at the top. The first term is minus cos theta sine theta, and the fourth term is sine theta cos theta. Clearly these two cancel one another out, so we can just get rid of them both, leaving I cos squared theta plus I sine squared theta on the top. Let's rewrite this as follows: I cos squared theta plus sine squared theta in brackets, and underneath we have cos squared theta plus sine squared theta in brackets. So clearly we can cancel out the cos squared plus sine squared, top and bottom, so we're left with the incredible simplification, f prime theta over f theta equals I. That's pretty elegant already. Let's integrate both sides. Here we go. We'll write the integral f prime theta over f theta d theta equals integral I d theta. We're integrating with respect to theta. Now, to integrate the left side, we have to remember from calculus 2 that the integral of 1 over x dx is ln x, or ln x, natural logarithm x. So with that in mind, we integrate the left-hand side, and we get ln f theta equals I theta. The integral of I, which is the constant, is I theta. So we're going to swap these terms from one side to the other, so that on the left we have I theta, and on the right we have ln, and let's write out f theta in full. We have ln brackets cos theta plus I sine theta. Now, we can unpack the natural logarithms and say that on the left we have e to the I theta, and on the right we have cos theta plus I sine theta. So there we have it. We've derived Euler's formula. One final step, we give theta the specific value of pi. So on the left we have e to the I pi, and on the right we have cos pi, and cos pi is -1, plus I sine pi is 0. So there we have it. Euler's identity, e to the I pi equals -1. Cheers.